Okay, you guys have been learning rational functions. Just take a step back for a second and say, that's a rational function. Do you remember what it kind of looks like? Everybody make a little sketch of what that thing looks like. It's a parent function now that you're supposed to know. There's a whole bunch you're supposed to know. And I'm going to remind you. The simplest, y equals x to the 1. Do I really need the 1 there? No, but I think you'll see the pattern. You need to know what y equals x looks like. Straight line going like this. You need to know y equals x squared. Parabola. You need to know y equals x to the 3rd. Remember this one? A triple root. And you also had one where it was y equals x to the 1/2 power. Do you even remember what that is? It's a certain kind of root. Does that ring a bell? 1/2 power means square root. That's the same exact thing as the square root of x. And you remember what that looks like? Look like that. You with me so far? All right, so what's this y equals 1 over x thing? Well, it's just right in here with all these other ones. Y equals x to the -1, which is 1 over x. So these are just, if I review, x to the 1, you've been doing that for a long time. X squared, x to the 3rd, x to the 1/2, and x to the -1. And that's the one I just asked you to sketch right here. 1 over x is x to the -1. And what does it look like? Let me scroll up a little bit. It's the one where it has asymptotes here and here. I hope you know what horizon means. It's like horizontal and horizon kind of go together. That's this one. The horizontal asymptotes, we're not talking about that much today. We're going to talk about the vertical asymptotes, this kind. We're going to talk about how to get that today, and holes. But here, that's the big picture. That's 1 over x. Okay. So what would you have to do with that? Well, if I asked you to graph it, or say where the horizontal or vertical asymptotes are, you should be able to do that. That bottom part, that means move it to the left too. And it also messes with, if I move to the left, do you get, that's going to mess with, I'm going to make it bright pink so you can't miss it. That's going to mess with that asymptote. If I move it to the left, the other asymptote won't even change. But if I move it to the left, that pink asymptote will have to move to the left also. That's the vertical asymptote. Notice the stuff down here, that messes with the vertical asymptote. So today's mission is to be able to give you an equation like this. Everybody write this one down, please. And help you understand what the vertical asymptote is, what the domain of it is, and if there's any holes. All right, so it's all about the base today. If I can make the top 0 by putting in -3, I don't care about the top being 0. One of the fundamental things about math you have to understand is this. A 0 on top, not a problem. The answer is just 0. Okay? But this, that's like the world ends, the function implodes. It's really bad. Can't have 0 on the bottom. All right. So it's all about the base. And those two things that are troublemakers in this case, it's kind of like, I've given the example before, it's like the function is allergic to -4 and -3. It'll have a reaction. Now, do you get, some people are allergic to things just on a really low level. Like, I get bit by a bee sting and it swells up more than usual, more than for most people. Whereas other people, like, they react in a whole different way, like severe, like they could die from it. All right. Well, this has two different reactions. This kind, where there's nothing up on top to go with it, that is the vertical asymptote. kind of reaction. It's still a bad thing. The function can't handle that, but it reacts with an asymptote. Whereas if there's something on the top and the bottom that are the same as each other, can't they just cancel? Yes, but that creates a problem in the graph called a hole. So if there's one that's the same on the top and the bottom, see how there's an x plus 3 on the bottom and the top? Then that creates a hole. So this function, if you look at its graph, you would see that it is happily going along with a nice smooth line until it comes up to the negative 3. And at the negative 3, it's a hole there. Let me show you what this actually would look like. I'm going to pause for a second. Okay, so I've pulled this up on a website called Desmos, and I've graphed x plus 3 over x plus 3, x plus 4. And can you even see the asymptote? Like, is it a dotted line that's visible to you? No, but can you see where it must be? This is kind of like astronomers looking out into outer space. They can't actually see a black hole. It's a black hole. It sucks in all light. You can't see it. But you can tell where it must be by how things nearby are behaving. So when they look out into outer space, they see the stuff around the black hole, and they're like, ooh, there must be a black hole there because I can't see anything there. All right, so I'm oversimplifying, but I can't see the asymptote, but I know it would be there. Now, why can't I see this hole that I've talked about on Desmos? Well, because right here at negative 1, 2, 3, there should be an empty spot right there. And I really wish that they would somehow call attention to it, but it comes down to this. How wide is any point? Do you remember this from geometry? How wide is a point? If I said negative 3 on a number line, how much room does negative 3 take up? You guys don't remember this from geometry. Maybe they don't even tell you this in geometry anymore. The number negative 3 on a number line takes up 0 space. Because what does it do? It's supposed to do? Is it supposed to take up the spot between negative 2.9 and negative 3.1? Because that's going more than just itself. You know what I mean? Like, how is it supposed to, should I make it this big and then it'll go from negative 2.5 to negative 3.5? How wide should I make it? So a point takes up no space on a number line. So technically, you see how I can't see that there's a hole right there? There's supposed to be a hole right there. It's because all the points that lead right up to it and all the points that start right after it fill up that space. All right, so I wish, and this is how you'd have to graph it on your test, you'd graph this like you normally would, which is the parent function, it goes like this. And then you have to find where negative 3 is. Negative 1, 2, 3. Follow it up to where the graph is, and you put an empty spot like that. That one little spot doesn't work. And the reason that your graphing calculator, that I could ask you to pull it out, and I have you graph it, and it would do the same thing. You can't see that there's any hole there. Because, by definition, how much space does a point take up? Doesn't take up any space. So we know that if you put in a negative 3 here, you're going to end up with a negative or with a 0 on the bottom, and that means problems. It's dysfunctional. And it won't work. And it's causing a hole. All right, so this is what your graph would look like. An empty spot right there. They do cancel out, but you can't act like nothing happened. I get what you mean. If they cancel out and I say the answer is 1 over x plus 4, that's kind of what this graph looks like. In fact, if I retype that in, 1 over x plus 4, it would be in the exact same spot. But this one has a hole in it, which means if I feed that function a negative 3, it won't work. And the way I signify that is by making a little empty spot on the graph right there. Yes? I get what you're saying, but 0 over 0, either way, it's a problem. Would you agree that there's a 0 on the bottom? Okay. So 0 over 0 is a different problem than just over 0. You get what I'm saying?
Yeah.
Okay, because dividing by 0 is the fundamental main problem. But when you have a 0 over a 0, it's obviously a unique situation. Anything divided by 0 is just supposed to not work. But when you happen to have a 0 on the top and a 0 on the bottom at the same time, that creates this hole I'm talking about. All right. So does this one still have a problem? Yeah, it's still got a problem at -4. That's why this blue dotted line I was putting in there, that's why that blue dotted line is there, because it can't have any answer at -4. I'll just put your pass on the table here. All right, so what I'm trying to tell you is that this graph fails in two ways. -4 kills it and -3 kills it, but they kill it in different ways. It would be comparable to a person with peanut allergies who also has an allergy to broccoli, but broccoli just makes them a little itchy, and peanuts would actually kill them. It's two different reactions. They're both bad for them. All right, so this function has two things that hurt it, but this one does it as a whole. It's just an empty spot on the graph. All right, so let's look at a more normal one, and it's like this. Y equals x plus 5. Everybody just graph y equals x plus 5. Just draw me. That's a nice, simple, it's got a slope, it's got a y-intercept. Just draw that graph. So imagine for a second you just have this graph, but it's got one little weakness that it didn't mention. This is like political candidates. They have to ask them all kinds of tough questions because, like, it's going to come up eventually. They're going to find out if, oh, by the way, I used to be a spy for the Russian government. Oh, that's going to come up. That's going to be a big deal. We better get that out. What if we also found out, oh, this used to be this? Do you get that that's different then? It has a weakness. What's this function's weakness? It is a hole at what? -4. So before I knew that, I just would say, okay, well, then it goes through 5. It's got a slope of 1, so it kind of looks like that. You with me? Goes forever, doesn't have any weaknesses. Oh, but wait, it actually has a weakness? Like this? Then that means this function, wherever 4 is. Wait a minute, I should have said -4. Hold on, just hold on. Okay, would everybody please change that to x -4 and x -4? And now you were asking, do you think that this function is graphed wrong? Because it's just this. And I know it's been a long time since we've just graphed plain old normal ones, but that's got a slope of 1 and a y-intercept of +5. It is correct, and it's okay. Happens all the time. You're not the only one. Okay, now I'm going to make this have a hole at 4. I go up right there, and then that's a spot that can't work. So I'm going to actually use my surgical eraser, a little tiny eraser, put a spot right there, empty spot. Now, technically, that's supposed to take up 0 space. Then how would you even note that it's got a problem there? So we call attention to it by, like, circling it. It'd be comparable to the dentist puts up a x-ray of your tooth, and you might not even tell that there's a cavity there, but he's like, can circle it and go, look at this spot. See how it's darker than the other stuff? And that means you got a cavity there. And so, anyway. So we're calling attention to it by circling it. All right, so I'm going to give you another equation. Your job would be figure out what its weaknesses are, things on the bottom that make it 0. Figure out whether those weaknesses are holes or asymptotes. Okay? There's three things that would crash this function. But it crashes it in different ways. It either crashes it because it's got an asymptote there, or because it's got a hole there. Can you have more than one asymptote? Yes. Can you have more than one hole? Yes. I think for most of you guys are smart enough to realize that that was the thing. It canceled out. And it's okay to rewrite this equation as y equals 1 over x minus 1 and x minus 7. But you can't act like it never had a problem with negative 1. You have to realize that negative 1 was a weakness for this function. So when you graph it, yeah, you're just going to graph this, but you'd have a hole at negative 1 because of this. So the hole would be at negative 1 comma what, Mr. Server? Hint, don't say x equals negative 1. That's how you say an asymptote. A hole is at negative 1 comma something, like a point, you know? And where's the rest of the point? You put the negative 1 right here. So it's 1 over negative 2 times negative 8 positive 16. The whole would be at negative 1 comma 1/16. That's exactly where the weak spot is on the graph. And the asymptote, and by the way, this is a vertical asymptote. Those are always x equals things. Just a quick reminder, vertical, zertical. Remember that dumb little saying? Just trying to help you remember this. Verticals are x equals things. X equals what? 7, and what else? 1. Those are the asymptotes. X equals 7, x equals 1. Now this is too tough to graph today. We'll eventually get there. But for today, all you'd have to be able to do is say, yeah, there'd be a hole at negative 1 comma 1/16 and an asymptote, vertical asymptote, at 7 and 1. So the three things, well, those are either holes or asymptotes. And the last thing I have to teach you for today is, what's the domain of this? Domain is what can you safely feed this function. It's like you have a dog, you can feed him most foods from your table, but what's the one thing you can't feed your dog from your table? You can eat it, but it can't. Grapes and chocolate. I have heard about chocolate many times, but I haven't, maybe you maybe even mentioned the grapes thing before. Are you sure?
Oh, grapes are terrible.
Really? Interesting. Didn't know that. Well, I know you can't feed them chocolate, but doesn't mean they instantly die from chocolate either. It depends. It really does depend. I know we had a family dog that we brought to the cabin, and it was like causing too much trouble being loud, so we like just threw him into the bunkhouse because we knew everybody had there was bags and sleeping bags and stuff in there, but we didn't think there was anything in there. And then Grandma goes, "You put him in the bunkhouse?" She said, "I was storing the cinnamon rolls in there. They're underneath the bed." So we went in there, cinnamon rolls are all gone. And the dog has eaten like 24 cinnamon rolls. And this is a smallish dog. And we were actually really scared because do you know what happens when you then let the dog drink water? The cinnamon rolls will swell up inside its stomach, and it can cause the animal's stomach to tear, and they can die from it. So we were like on pins and needles, for like 3 days trying to feed it only a tiny amount of water to make sure that it didn't like have the stomach explode. And it survived. And then through some figuring out, somebody had also brought a small cake it turned out the dog had not only eaten the 24 cinnamon rolls, it had also eaten a cake. And they were like, you never have to worry about your dog again, because we figured out it also ate a chocolate cake, small albeit. Anyway, fun family story. That was the same dog that got sprayed by a skunk. You guys know that they do spray, right? Have anybody actually smelled it when something has been sprayed? Oh. So I'm guessing, did the dog get hit in the eyes? Okay, because that's the critical thing, because it can actually blind the animal from the skunk spray going into their eyes. It's not an instant gonna go blind thing, but it has a chance of causing the animal to go blind. But it's obviously, the smell is just insanely terrible. Anyway. All right, so what is this function's weakness? Hint, if you can factor it, you should. So, it will have weaknesses. Those weaknesses are things you can't feed it, and therefore the domain is everything except those things. Like the dog, you can't feed it chocolate, or apparently grapes or raisins. Which raisins are just shrunken grapes, so that makes sense. So this thing's domain, I like to do it on a number line, just because I think it's the easiest way to say everything except. So it's everything except positive 1 and negative 1. Why do I say that it can't be those? Because those two numbers will make the bottom 0. This is a way to write the domain. If you would rather write it this way, negative infinity until negative 1, union, negative 1 to 1, union, 1 to infinity, you can do that. I personally like the number line better. And I know where you're headed. In pre-calc, we allow either one of those notations. What that's saying is you can safely feed this function everything except those two numbers, negative 1 and 1. Where did I get that from? Gracie, where did I get the negative 1 and the 1 from? Yes. Excellent. Those are either vertical asymptotes or they could be a whole. Now, did you factor the top? Did you notice that this canceled this? And therefore, the negative 1, it's a problem, but it wasn't an asymptote. There wasn't two asymptotes on this one. It was one asymptote and one whole. The negative 1 that would crash this function does it in the style of the whole, which means that it'll have a little empty spot on the graph. Everything else is fine. But this, that one's a vertical asymptote. So the next question would be, what was the whole and what was the vertical asymptote? Well, the vertical asymptote's the easier one. You just get to say x equals 1 is the vertical asymptote. But what about negative 1? It's a whole. So you say negative 1 comma, and I, in my opinion, think this is the hardest part of your next test. Is to take this and solve for the y of the whole. Okay, my screen is blank. I feel like you were working on something else, maybe. Okay. If I put that negative 1 back in the function, you'd have a problem because the whole function would just crash. How are you supposed to know where the whole is if you put it in and it just crashes? You don't put it in that one. You put it in the one that's left. I wish I could expand this page to the right, but I can't. So if I could, I would highlight that's still left and that's still left. I'm going to bring it down here and say that's x plus 2 over x minus 1. That's my resulting function. Is that exactly the same as the original? No, because something canceled. But it's the simplified version of the original. X plus 1 over x minus 1. Or sorry, x plus 2 over x minus 1. That's where you put this. Remember, why didn't I put it in the original one? It would just crash it. So I have to put it in this simplified one. And I put in a negative 1 there and there. And that makes negative 1 plus 2 over negative 1 minus 1, which is 1 over negative 2, negative 1/2. Who beat me to it and had negative 1/2 there already? Awesome. All right. A lot of people think you can't factor this one because it's not like a 9. If it was a 9, you could do it, Mr. Server. X plus 3 and x minus 3. But do you get this one does factor into x plus 1 and x minus 1? All right, let's do one more like that. Last one, and then I think we're ready to start the homework. So stay with me, those of you that are drifting a little bit. I'm almost done. Y equals 3x squared plus 2x plus 1 over if you can factor it, you should. On the domain, number lines are so much easier. Everything works except these two things. Then you further clarify to say which of them is a whole and which of them is an asymptote. And this is vertical asymptotes. Technically, you're going to learn about horizontals later. Now, I upped the difficulty level of the factoring a little bit. I hope I didn't go too far. Did you figure out it was 3x and x? And then, really all you got to do is figure out, well, it's only plus signs in it, so it has to be plus and plus. And then what do the numbers have to be? Well, to make a 1, don't think about making the 2. Just think about making the 1. How do I make the 1? 1 times 1. It's got to be a 1 and a 1. And then to make sure it actually worked, I would check these two, because I already checked the first and the last. But the outside and the inside need to make that, and they don't. So that does not factor. Is that okay that that doesn't factor? Yeah, it's okay if it doesn't factor. That means that the two weaknesses that this thing have are both what's? They're both asymptotes, because there isn't anything for the to cancel the x plus 7 and the x plus 1. If there's nothing to cancel those, then they are still weaknesses. Do you get if I put in a negative 7, this function will crash? But the domain was just saying, what are its weaknesses? The two things are negative 7 and negative 1. Can't be either one of those. Can be everything else. To me, that's way easier than writing the thing with the infinities and the commas and all that stuff. If you really liked interval notation, go ahead, write it that way. Okay, whole. What's the whole? None. There wasn't a whole because the top didn't factor. And what are the asymptotes? There's 2 of them. I hope you didn't think that there was always only one. The 2 things, these 2 things had to be something. There were weaknesses for the function. They kill the function. They either do it by being an asymptote or a whole. And we figured out, since there was no factoring, it couldn't be a whole, so they had to be asymptotes. So these are horizontal, nope, vertical, sorry, vertical asymptotes. Okay. That's typically what your whole homework assignment is like. All right, so let's go find your homework assignment. I'm going to pause for a second while I pull that up. Okay, so here's the worksheet. I hope you noticed if you can factor it, you should. X minus 3 on top. 3 comes out. X minus 3 on the bottom. Ooh, it canceled. Now I'm going to write out really clearly what I have left. Y equals 1 over 3. Why is that important? Because we're trying to find out where the hole is. And if you just say x equals 3, you just wrote an asymptote. You may not write your hole that way. The hole is a point. 3 comma what? So it's 3 is the x value of the hole, but what's the y? You plug it back in, but you have two choices. You either plug it into this one and just watch the function die, or you put it in that one and like, well, what's y have to be? It's 1/3. Don't overthink it. There's nowhere to put it. There's no x in here. So y is always 3. No matter what the x is, the y is 3. So the hole would be at 3 comma 1/3. Like I said before, I think this is the hardest part. It's not that hard though. To get this number, it's a y value, right? So y equals, it comes from this, and you just have to simplify the function and stick this 3 in it. But in this case, there wasn't any x. There was nowhere to put it, so y is just equal to 1/3. All right, this next one, after this cancels, I totally get you just have nothing, right? No, you have a 1. So y equals 1. Notice me sum that up as a y equals thing. Now, was there a hole? Yeah. What was the thing that would cause this function to crash? A -5 comma 1. We just need to know the y value, and y is 1. All right, keep going just like that. And then when you get this far, I thought 9, 10, and 11 were all good ones to skip. Now, I know, still a lot left. And I want to help you with these last 3. I'm not going to do all of them, but I'll do one of them. Look at this graph. I know, it's got a hole in it, which is the scary part. But let's just get most of it done, and we'll deal with the hole at the end. Imagine for a moment that there was no hole right there. Just imagine that as a perfectly normal parabola. What's the equation for that? Because it's going to be really close to that. You start with that. Isn't this just a normal parabola, which is x squared, except it's shifted where? Down 4, so I'm going to go -4. There's my equation for it. But wait, there's more, because it has a hole. Do you get that? Means it must have been a fraction function with something on the top and something on the bottom that canceled to make that hole. And what must have been in there? There are always x things. Come on, you can finish this. It's at -1 right here, so you'd want -1 to make it equal 0. So you're right, +1. That way the -1, when put in, would make the bottom 0. There. Now one last thing, and if you forgot this, you'd lose 5%. It needs parentheses there. I know that seems like a small thing, but those parentheses, if you don't have them there, only the 4 is being times by x plus 1, and that would make it a completely different graph and wrong. It can be factored, yes. But since these ones are going to cancel, there's nothing else that can cancel. So it's one of those times where if you can factor it, yeah, you should. But you get the reason we cancel stuff or factor stuff is so we can cancel stuff. And if there's nothing to cancel, then it doesn't really matter. Now, you might even like it in factored form because you'd see it was the -2 and the +2. It'd be totally fine to leave your answer like that, but then you got to still put the whole on top and bottom. So then I'd have to put an x plus 1 here and an x plus 1 there. So if you want to do it like the red writing, that's okay. I do love that you're thinking about factoring. That's a good thing. All right, there, I did that one for you. Now, a lot of people are like, well, yeah, that was the easy one, Mr. Server. What about this one? What did I say again? Don't act like there's no hole. And just what's the equation if there wasn't a hole? Y equals 1. And then you have to go back in and put a parenthesis on the top and the bottom and figure out what would have been in that parenthesis. Must be about this negative 2 here, right? So figure out what would have to be in the parenthesis on the top and the bottom. This one, same deal. Act like there's no hole. Figure out, oh, it's just a slope and a y-intercept. Unless you've forgotten about the y-intercept thing, like some people I know. Anyway, now you just put a parenthesis on the top and the bottom to make the hole. All right. I know it's kind of an intense day. It's a rough day for a Monday. Tomorrow is theoretically the last day. Wednesday's a review. Thursday's a test. What's on Friday? It's a good question. Yeah, that's one of the reasons it's not on Friday, because there's going to be probably typically 2 people in each class that are gone on Friday. And I can get to it, so why not get to it on Thursday? Then I can theoretically have them graded and back to you on Friday before we even go on break. Otherwise, it's kind of like weird. If I give it to you on Friday, you won't see your results for 16 days. So I'm going to try to get it done Thursday. All right, that's all I have for you for today.